Hey guys, how's everything going? This is JSer. In this video, I'm going to solve another problem from BFE.dev. It's 136. Find median of two sorted array. Let's take a look at the description. Given two sorted array of integers, please return the median. The median means the number in the center, right? So 1, 2, 3, 4, 5. There are 5 numbers, and we need to return the 3, which is in the middle. If they are even numbers, return the average. So for 1, 2, 3, 4, we should have 2 and 3 as the center. So we return 1.5. So what is the time and space cost of your approach? Could you do better? Obviously, we could do naively like merge them together and sort and get the median, right? But it doesn't take advantage of the sorted information. The array are already sorted. So let's first analyze with the brute force approach. So we could merge them and then sort. So we merge them, it would be n plus n, right? And then we sort it. Sort would cost us n plus n log n plus n. So if you total say if there are n numbers in this array, I would say it would be the time complexity for the sort. It costs the most. So it should be n log n. Okay, could we do better? Because they are already sorted, I would say we could take advantage of something related to the binary search, I would say. Let's take a look at the most simple case as described here. So if this 1 and 2 and 3 and 5, 4 and 5, because they're already sorted, we actually could get the median of each array, right? So it would be something like, okay, this is not simple. Let's get the 3 here. The median should be 2, and here is 4. If we get the median and cut the array into halves, like something like 1, 2, 3, and 3, 4, 5. There might be more numbers here, 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 right? Okay, now the array becomes 4 parts. If say 2 is smaller than 4, or they both are equal to 2. If the median of first array is 2, the second is 2. Then we are sure to say that median of the whole array is 2, right? That is a simple case. If one is smaller than the other, like 2 and 4, because so we get the median must be falling within this within the subarray, like the subarray of this part and this part, right? If 2 is smaller than 4. Reversely, if the first array median is bigger than the second one, still the median of the whole should fall in the range here. Why is that? We could suppose that let's say the median here is median 1 and here is median 2. If it is smaller than it, and the subarray to the left of these two medians have the same numbers of the subarray to the right of these two of these medians, right? If this is smaller than this, it means the median cannot fall here, because if it falls into this array, then it is smaller than this median, and it is also smaller than this median. It's impossible, so it can't be put here. And the same would be if it falls to the right here at this part, then it is bigger than this median, right? And also this median is bigger than this one, so it's still bigger than this one. No, it's bigger than 2. So it falls in this array, it falls in this array on the right part. We both fall on the right part, then the numbers, the count of the numbers bigger than the median will be larger than the smaller one, right? So this 5, it cannot be in the 5. By these, we could deduct that by comparing the medians of them separately, we could safely cut off part of the array, right? But to keep the balance, we need to cut only the same amount of numbers. Suppose there are like 3 numbers here, and then there's only 1 numbers in the second one. We cannot cut 3 of them. If we cut 3 and cut 1 here, it is not balanced anymore. So we could only cut the 5 here, right? We could safely cut the 5 here, and only we remove 1 item out, like this. And then we could do this over and over again, right? Yeah, and the median we need to consider of the even numbers. So at last, we could at least remove 1 number. And at last, we meet the case like there is only 1 number, or there are 2 numbers, right? If there are 3 numbers, we could always get a number in the median and try to cut something out, right? For a case like this, we get the median here is 1, and this is 2. 1 is smaller than 2, so we could be able to cut down. Oh no, we cannot cut down because there's no number here anymore. We need to be both, say they must be both longer than 2. If there are 2 numbers, we couldn't cut because these should be treated as a median as a whole. So at least 3 numbers, right? We could only be approached. So we could recursively cut off the shorter half, until one of them has less than 3 numbers. And once that is true, we could wait a minute. If the other one is very, very long, we could 3 numbers we get, and there's 2 numbers, so we can merge them, right? And then we could just merge constant, say the array of 2 item less than 3 with another array. Well, because there's only 2 items, constant items, we could say the merge will be very easy. So it could cost us only linear time here, I would say. And this one, recursively cut off the items, like the binary search, roughly, I would say they have the O log n. Because every time we cut half of them, roughly, I would say. And then, so this is our final, the time and complexity of our final approach. It would be actually linear time plus log n. Log n is better than worse than the linear time. So this is the final time complexity. Okay, this is my approach. There might be some better ones. Okay, let's begin. So the key to each iteration, each process would be first we get the median, and then get the numbers of each part, right? So yeah, let's define a separate function for that. Let's say function get median. We get the array, and then we also need to keep track of the index. So that would be start and end. Okay, so the count of the subarray would be n subtracted with start and then +1. Okay, if count is odd number 1, then we could just return the center would be array. The center would be end 0, 0, 1, 2, 1. Okay. Start plus end divided by 2. Yeah, this is a median. And the length of the left part and the right part would be count subtracted with 1 and then divide by 2, right? Great. And then if it is a not odd number, what we do, we return it. This will be in the middle. So the index, I would say, would be okay, left index. Math floor array left index plus r plus 1, get the average. Yeah, and then the length of left part and right part, that would be easy, right? That would be count divided by 2 subtracted with 1. So this is it. This is the get median number and length. Okay, so we would do this with a while loop. Okay, let's start 1 equals 0. Let end 1 equals 1. And then let start 2 and 2. While end 1, we stop if one of them is we stop when one of them has less than 3 numbers. So 0, 1, 2, it should be 2 as the difference. So if while end 1 start 1 is bigger than 2, and also end 2 start 2 bigger than 2, we would compare the median and cut them off, right? So we get the medians 1, get the median. Okay, here is median 1, length 1, get a median number and array AR 1, start 1, end 1. Median 2, length 2, get median AR 2, start 2, end 2. Now, if median 1 equals median 2, we just return it, right? And we're done. And if median 1 is smaller than median 2, as we said, we need to cut the left part of the first array and the right part of the second array, right? So say to cut off, I would say count number to cut would be the minimum, right? We cut the smaller one of the length got from this function. Okay, numbers to cut. Either way we would cut. So cost number to cut would be math minimum length 1 length 2. If it's smaller than it, if we get the number, yeah, it's okay. So we cut the left part off. We cut off by moving the index of the start one, right? So start one plus, if cut one off, we move it one further. So we plus it, and end 2 we would do the minus negative, right? We move the end index to the left. So we subtract the end index with the number to cut. And then we would do the same opposite way. Here we would be end1 negative and start 1 plus, right? Yeah. And then we get the an array of, we get two array. One of them cut off to max 3 items. 2 items, right? As we analyzed, less than 3 numbers. Equals 2. Okay, I'm sorry. If there are 3 numbers, we could still be able to cut them off. So one of them will be 2 numbers. Okay. And then we merge them. How can we merge them? Well, I think we have done the problem before. I will copy it. I think it was merge sorted array. Oh, I haven't done it yet. 2? There the 2 version? No. Okay, I'll create another function here. Function merge to array. Okay, I will not create a separate function because we're keeping track of the index here. Yeah, it's okay. Or no, we don't need to merge them. We could just move 2 pointers and then let's say the first array is something like this, and the second array might be longer, might be shorter. We could just compare the first one, and then if it is smaller, maybe this is another approach. We just keep popping, right? But that, I mean, that's better. Okay, I'll try to do this, and then we try to solve it without this binary search stuff. I think it is also approachable. But this one actually is if the I would say if the array is balanced, this is better, because if it is balanced, we could obviously expect that this to be smaller than small enough to small enough to only keep the log part. This is better than the linear time, I would say. If the array is not balanced, then yeah, it doesn't make a difference than just doing the process we're going to do. Okay, we merge them, so we don't actually need merge them. We use two pointers. And count the stuff, and keep moving and counting, and finally we return the result. Right? Yeah. So the finally the left start one and end one, start two and end two. The left, I just use array. No. How should I do this? I'm thinking about creating a new array or not. If not, we just loop through it and count. Oh, okay. I'll just create a target 1 and target 2. Yeah. Okay. The left count left b. Okay, count rest would be end 1 subtract with start 1 plus 1 plus end 2 subtract with start 2 plus 1. So target 1 will be, if it is a not number, the target 1 and 2 is to keep track of the center, the median index. So if it is target 1 would be, if it is odd, then it should be plus one and divide by 2. Yeah. The index, right? There are 3 numbers, then it should be 1. Okay, I'm sorry. It should be -1. If it is even, then it should be 0. Yeah, like this. And target 2, if it is odd, we actually do the same. If it's even, like there are 2 numbers, it should be, yeah, there's no -1. This is it. And we would while start 1 is equal to end 1 and start or start 2. This is verbose. This is not okay. If we if we're going to pop the numbers, okay, so enter 2. We actually need to count, right? Okay. One of them. Okay. So if target 1 index, this index, target 1, let target 2, let count equals 0 now. So if, okay, while or, right? If both of them are true, we would compare it. If one of them are true, okay, I see. Wow, this is not cool. This is not very cool, I would say. If these are true, if it are 1 start 1, what if they are equal? If they are equal, they don't matter, and they just doesn't matter, right? Which one is before the other one? Okay, no problem. So if start 1 AR2 start 2, then we move the start 1 further, right? We move it further, and anyway, we would count it up. So the index, if we're going to get the 0, then the 0 here, it should be before the increment, right? Okay, if count is bigger, oh, there's no need to count this. Start 1 plus 1, and then the target, and target should be, oh, I'm totally confused how to write a elegant code here. ARR1 start 1. For the other case, we would get start to 2, right? Target to ARR2, start 2. And for the other case, if this is true, means the second array is gone, we would do the same here. For the other case, we do for the second one. Wow, this is not cool at all. So if count is our target 1. Oh, if count is target 1 index, target target 1 equals target 2. no, target 1 equals target. And if count equals target 2 index, target 2 equals target, and also we break. We stop. Right? Yeah, and then we just return target 1 plus target 2 divided by 2. Ooh. Yeah, finally we have completed the function. Let's try to run with some sample. Median is 1, 2, 3, and this is 4, 5, 6. The median should be 3.5. Not a number. Oh my god. What's the problem? Okay, start 1 and 1, start 2 and 2. 1, 2, 0, 1. So finally we fall 1, 2, 0, 1. So this is right actually. The problem comes here. Target 2, target. Okay, we log the target, okay? So log the target. 2 and 3? Yeah, 2, yeah, 3. And then we stop. 0, 1. There's a problem of target 1 index and target 2 index. Target 1 index, target 2 index. 1, 2. Okay. And we got target is 2, 3. Yeah. Target is start 1, 1, 2, 2. Yeah, we start with 2 target. And count. Let's log the count. And also we log the target index. And then target 2 index. Okay. Target is 2. Count is 0. Targeting is 1. So they are not equal to each other. And then we just increment the count. And then we got 3, right? 3. We get the target 3. We get the count 1. Targeting is 1. So we fill the target 1. And then target 2 index, they're not equal. So we move on. And then target we get undefined. Why? Okay, start 2. Oh, this is not. Start 2. This is not true anymore, right? When we get the 1, 2 here, 2, 3, we've already moved the start 1. Oh, here. What? Oh shit. If start 1, we would do the same for actually array 2. I'm so stupid. Oh great. Oh yeah. Look. We get the index 1, 2. Looks good. Let's try it for the 7. If the case like this, we get 4. Oh, great. If there is a 1, we should get 5. Oh, nice. Great. So let's remove the log and hope it passes. No, it's not passing. For the case like this, we okay, console, okay, median, log median. It's not. It's not very obvious to use the index, so I would log the console log the subarray. Okay, AR1 slice start 1 end 1 plus 1. This is AR2 start 2 and 2. Wait a minute. And 1, right? This is after the while loop. Okay. The case here says we need to expect 590, but we get 570. Okay, let's take a look. 590. 590 here. We get 570. But actually, after we've done the while loop, there's only 638 left. So actually, we removed too much numbers, right? Let's log it down. 1 console log. We would log the same here. First this is the original array, I would say, and then we only get one punch. This is not right? 9 and then 1. Wow, this is not true. There must be some problems here. Oh, I found it. So start 1, we move to the right, and 2 moves to the left, and then we should move 1 to the left and start 1. Okay. And then end 1, and should be start 2. Oh, okay, this is right. I'm so stupid. So forgive me, I made a lot of mistakes here. Great. Wow, this is super. I think this is a hard question. Allow me to remove the console. Actually, I would say this actually would be good. This could be enough for if this array is balanced, is unbalanced, right? I will remove this one. It still should work. Yeah, it should still work. I'll post the code separately. Okay. Okay, how should I do it? Okay, I will to the count here. I submit it. There's no need for get the median anymore, right? Okay, I know what to do now. I copy it and then move it and remove the while loop here. And then I remove the code, count, and then get the median with 2 pointers. Submit. Good. I posted 2 pointers. So the time would be a linear time, right? ON. Time. Great. I'll post it. Another one is this. This is possibly would be better. For worst case is linear time, and we could for improve it with log n here. I post it. Binary search. O log n. Worst case is linear time for unbalanced number. This is it. Okay. Yeah, I posted. Wow, this is much harder than I thought. Yeah. Anyway, hope it helps. See you next time. Bye bye.